series puts a spotlight on the AI builders. You know, those developers who really take LLM and put them in production. And by that, they're getting all the bugs, all the issues, all those damn edge cases that you just don't get when you build a nice demo for a fancy hackathon. Because let's face it, there's no playbook, right? This is like an uncharted territory, and we really want to hear from the people who are there. So join me as we deep dive into AI without the BS. In this episode, I'm speaking with Niv Granot, an algorithm group lead here at AI21. Niv's group is working on tools, namely external tools you can connect to LLMs to create systems. Specifically, we're going to talk about RAG, which is part of very well-known RAG processes. We will talk about how those RAG benchmarks were built, what is the problem with it, which is locally focused and really extraction-based. We will offer solutions on maybe how to build better benchmarks or how to better utilize the existing benchmarks, and really give some tips on how to do the best RAG system you can do. Hi everybody, I'm Yuval, and today I'm here with Niv. So, hi Niv.
Hi.
Tell us maybe a bit about yourself.
Yeah, sure. I'm here at AI21 for the last 3.5 years. I've started working here as an algo developer in Wharton Wright. And then I became a team lead in Wharton Wright, and moving forward to the agent endeavors of the company, currently leading the tools effort, which means that we develop tools for the agents, and specifically knowledge-intensive tools such as Retrieval and web search.
Okay, cool. We'll go back a bit, right? Because we will talk about what you're doing in the company.
Yeah.
Can you maybe share a bit what happened before? For those of us who don't know you at all.
Yeah, for those of us who don't know me at all, unlike you. Before getting to AI21, I was in the Weizmann Institute doing my master's degree in computer vision. Studied at the Technion with you, and in the Weizmann Institute with you.
I will just give you brief information about Niv. He's the kind of guy when you're sitting in lectures and you're like trying to really understand what's happening, like all those formulas, and he's on his phone like checking soccer updates and stuff like that, and you have literally no idea what's happening, and then you're just like, Niv, do you know what's happening? I was like, oh yeah, you missed a spot on like line 6. And he always like, he's the kind of person that the average is like 60 and he gets 104. This is a true story, it's not just numbers. So this is probably all you need to know about Niv, one of the smartest people I've ever met and one of the nicest people I've ever met.
Thank you for all the embarrassing facts.
Anytime, really, if there's something I can do, anytime for you. So you've mentioned Wharton Wright.
Yeah.
Okay, one of the first generative AI applications in the world, really, in production. Mm-hmm. Can you share a bit about that? Maybe start with what is Wharton Wright?
Yeah, it's a writing assistant based on AI engines behind the scenes. As you mentioned, it was before the ChatGPT revolution and the generative AI everywhere. It mainly focused on paraphrasing and enhancing writing. And I was there. Super cool application, still alive, and I think gives users a great user experience to engage with their texts. And I think it's really great.
Yeah, so my first memory from Wharton, I guess you remember, Niv started to work here roughly 6 months before me. And when he wanted me to send my CV to come and work here, he used Wharton to help me write them because I didn't know how to write properly in English. So basically, through Wharton, I'm here right now. And
I'm here right now.
And now you're sitting here with me. Oh, so much fun.
Yeah.
So after Wharton, you now started to work on agents, right? So tools, retrieval, all this kind of fun. We're really close to get to that. I just want to ask you first, can you maybe describe a bit the first AI application you've ever built?
So I think you've heard this lecture so many times during our master's degree, but it was in our master's degree, and I've built like a generative AI application based on a single image, or generative model based on a single image. It means that you take one image, and then through an AI model, you can transfer it or transform it to many other images from the same distribution. Very revolutionary back then, very ancient history now. But
what was it called?
Drop the GAN.
Drop the GAN.
Yeah.
Such a good name.
Yeah, great name.
I'm guessing from the name, it was when GANs was all that.
Yeah, GANs was everything, and we suggested a solution that did not involve any neural networks, actually. We just went back to the basics of image processing, so it was really cool. And what was possible a year before that in like 2 minutes was then possible in a fraction of a second.
And now the fusion model came in.
And now the fusion model came in, and you know, the world has changed.
Yeah, but just like an FYI, again, I told you that he's a genius. This paper was actually shortlisted for best paper in CVPR. Look at him, so embarrassed, but he's really a genius. Such a cool guy.
Thanks again. I'm about to leave.
Not a cool guy at all. Just very, very smart. One last thing before we start to actually talk. Can you maybe give me a controversial opinion on LLMs or generative AI that you have?
I think they're not there yet. I think that people have the feeling that it's right there, that we are in the brink of transformation, and AGI is here. And it doesn't feel like that when you're really dealing with them with real use cases.
So today, what we're actually going to talk about, why I wanted to bring you here, is to talk about the problems with the current methods of RAG evaluation and how to build better pipelines of RAG. And it's really fitting, right? Because this is literally what you're doing here, right? Maybe remind us what you're doing.
Yeah, so I'm leading the tools team, which we build knowledge-intensive tools, which means that we help users retrieve content from their corpus or web. And we are trying to bring the exact content that the user asked for to help them with their queries.
Okay, so before we're going to dive deep, let's maybe do like a really short explanation of RAG, like the basics. What does it mean?
Yeah, so RAG is retrieval augmented generation. So there is the R part and the AG part.
Oh, you took it. That's my thing.
Your advice, yeah.
AG.
So we have the R part and the AG part. My team focuses on the R part, the retrieval. The AG part, I think, is pretty clear to people from the field. You just take the context and feed an LLM, and then the LLM should output the answer.
And based solely on the context.
Based solely on the context and without hallucinations, and there are tons of problems there, but I won't dive into the details of that.
Next episode, maybe.
Next episode. But let's focus on the R part. The R part means that you have a large corpus, thousands or tens of thousands of documents. And you would like to ask a question, and my job is to bring a short text segment that will help you answer the question. So this is the R part. What happens behind the scenes usually is that the text is broken into segments, and then each segment is transformed into some series of numbers or vector of numbers in some latent space. And whenever a user brings a new query, we transform this query into the same latent space and try to find which vectors are the closest to this query. This is the nominal way to go about it. There are many variants of what I'm saying now, many other ways to enhance the embedding mode, embedding phase, or any other phase, adding other blocks to what I just described. But this is the backbone that describes most of the RAG systems today.
So yeah, the basic RAG. So we said segments. Sometimes I think it's also referred to as chunks.
Yeah,
right.
Exactly,
so the
chunks.
Chunking part or segmentation. Sometimes this is the process of taking
the entire corpus and really divide it into small chunks of text.
Yeah, exactly.
Correct. And why bother? Even if we have all this text, why not just feed everything?
You have so much text. I mean, you have the Gemini have 1 million context window, 1 million tokens, and our clients have 500 million tokens or billion tokens in their corpus. So you can't just feed the entire corpus to the LLM. And the LLM has to work really, really hard to extract the right thing from an enormous amount of data. So you would like to narrow it down. It's just like asking, why search Google? Why can't I go just through the entire library or Wikipedia? Why use the search box?
Yeah, I get it. Like a stupid answer for a stupid question.
Yeah,
like,
exactly.
You got me here. I have nothing really to say about that. So let's say that, cool, you convinced me. I need RAG.
Yeah.
I want to build it. There's, I think, thousands of guides now. Like my first RAG, like the hello world of this process. Just take and retrieve, right? Chunk, index, retrieve, and so on.
Yeah.
And then build it. I want to see if it's good now. What do I do?
So there are common benchmarks for the different parts in RAG. Most of them are focused on the AG part that we talked about before. And there are many that are focused on a subset of the R part, usually the embedding model. And it tests the ability of the embedding model to find the closest segments to a given query. So you have like MTab or Bear or many others that deal with this issue. And you can go that way. So this will be a good start. But it will capture only a subset of this word.
So you're saying that I should test the retrieval part, and I'm testing the AG part, like the augmented generation part. How do I, like, what's happening in the middle? Like, do I, these two, each other, if I'm testing every part separately, does it ensure that the entire process works well?
Not exactly. Let me be clearer on something that I said before. You do not actually test the R part. You usually test like a subset of the R part because, as I said, the R part, the retrieval part, is composed of the splitting the text into small segments. But in most of these benchmarks, the text is already split into these segments in order to allow for a measurable metric that is precise and you can make sense of. But in real life, one of the main challenges is breaking the text into segments such that the segments contains both the clues that the user give you and the answer to the questions of the users.
You said a lot of words. Can you give me an example, please?
Yeah, of course. Let's think about a World War II paper.
Oh.
Yeah.
Very nice subject.
Yeah, it's a very cool subject, very modern. So let's imagine that you have a section about the reasons for World War II. And they have like 10 reasons, and every reason is a subsection. One user may ask you, what were the reasons for World War II? And if my text segment contained all of these subsections together, I will be able to answer this question. However, another user may ask me a question about a specific detail about reason number 3. So in this case, I am capturing a very large text segment, and I'm not very precise in terms of the details that are inside each and every subsection. So your goal here is to find the sweet spot where you can capture global attributes of the document that users may find interesting, and also capture the small details that users sometimes refer to in their questions.
You mean in every chunk?
In every chunk, yeah.
So essentially you're talking about a trade-off between like large chunks versus small chunks?
Yeah, exactly. When you have large chunks, you are facing a drowning issue. facts are drowning inside the chunk, but then you get a picture which is a high-level picture of the area. And when you go inside, when you zoom in, you get like the facts and the small facts, but not the overall relationships, and you may lose the coherency even. It
really shows that you have a background in vision
yeah.
when you use images to
yeah,
explain
I thought about
words.
it as well.
really shows. So, Niv, you talked about a problem, right? You gave an example, which now I can actually understand. But I know from you that there's more than one problem. So maybe just walk me through all of them.
Yeah, sure. So I think it was pretty clear when I said it before, but many of the benchmarks now are focused only on a single part, and not many benchmarks are testing the RAG end-to-end. This is one problem, but I think a more severe problem is the fact that usually people are creating the RAG benchmarks, and usually these are not the people that are really using these corpuses. So what happens exactly is that people are taking a Wikipedia article, for example, and focusing on a single paragraph. And they're saying, oh, there's that factoid there. Maybe we'll ask a question about it. So for example, natural questions is a good use case for such a data set.
Natural question is the name of the
Natural
dataset.
question is the name of the data set, exactly. So if you think about it, it's pretty much impossible for a human which does not know the entire corpus, because it's not their corpus. It's not your Google Drive, or it's not your personal directory.
Do you know everything you have in your Google Drive?
No, but I know the overall relationships in my Google Drive and what to look for. But in Wikipedia, when people are trying to build a benchmark upon Wikipedia, they are just finding themselves struggling with a single paragraph or maybe a single section. And when they go to financial documents like Finance Bench, they're looking at a single page or a single section, because this is what is cognitively possible when you're dealing with reading a lot of data and trying to ask questions. But actually, RAG is understanding the entire corpus, how it behaves, what are the relationships between different notions in the corpus, and how to utilize them to answer the user's questions.
So can you maybe explain more about all the problems with RAG benchmarks?
Yeah, so first of all, I think it was pretty clear from what I said earlier that there are mostly R benchmark and AG benchmarks, but not many RAG benchmarks.
But there are RAG benchmarks.
There are RAG benchmarks, such as Finance Bench, for example.
Okay.
But there are not many of them. But this is one problem that I think is more like technical problem. But the serious underlying issue under the RAG benchmarks is the fact that people are building them. So what are they doing exactly? They're taking a Wikipedia page, for example, and they're spotting a single paragraph, and they're saying, let's ask a question about that factoid in this paragraph, and your role in this world is to find the specific paragraph and feed it an LLM, and then the LLM should output the factoid that you looked for.
I get it. This is like the most simple thing to do,
yeah,
right? As someone who's not familiar with everything, maybe.
Yeah, exactly. So data sets like natural questions are facing such problems. And these problems are very prominent in real data. Users many times look for a specific factoid or specific extractive detail from their corpus. However, it's not the majority of cases, or not all the cases. Users sometimes look for a part that is an answer that is spread across an entire document. They are looking for things that involve relationships between different documents or between different parts in the same document. They're giving you clues to find the document which are not necessarily local. But the way RAG benchmarks are built are very, very focused on local performance, on your ability to look at a single chapter or a single page or a single paragraph and ask a question about it. So even the more complicated data sets, such as Finance Bench, is very focused on localization because it uses a single page to construct every question in the data set.
So you're saying, right, the localization is the assumption that once I find the right place, like there is a one place, right? That's the assumption.
Yeah, the assumption is that there is a single one place where the answer is can be found. And when you go to a more complex data sets that are looking at multi-hop questions, such as multi-hop hotspot QA or frames, what they do is they take several of these paragraphs or factoids and try to connect them through questions. But essentially, the underlying operations you are required to do if you find the right decomposition is the same retrieval operations. Find me the right paragraph that contains the actual information that I'm looking for. In real life, things do not look like it.
Okay, and also like the data actually represents real life cases there, or?
So if you take frames, for example, they have questions that are super challenging, but it's a good question if they represent real life use cases. You can find their questions like, if my wife's first name is like the first name of the wife of the 15th president, and her last name is like the last name of the company owner that built a company in 1847 that mainly sold cigarettes, what is my wife's name?
I literally lost everything you said up until the question part, so yeah, I couldn't have answered that.
So it's really difficult, but mostly what you have to do and what they show in their paper is that you should try to decompose again and again and again, but the underlying retrieval part stays the same. It's just like, find me the right paragraph and I'll be fine. So we deal mainly with the peripheral areas of the retrieval. We can add components before or after, but not many of these data sets tackle the inside of the retrieval part.
Okay, which is essentially, if I'm remembering correctly, both like the fact that the chunking part or the splitting part is not always ideal, and that like the core assumption of the localization is not really real. Like it's not real world worthy.
Yeah, exactly. Exactly. I think the image is much more complex than local facts that you would like to retrieve.
Another reference for an image. So, like I did before, you said a lot of words.
Yeah.
Give me an example.
Yeah. For Seinfeld fans in the audience, I'll give you one example.
I didn't know this podcast is aired in 1990, but sure, let's go with Seinfeld.
It would kill in 1990. For Seinfeld fan, I think that you can throw this on any show that you would like. If you ask any Seinfeld fan what is George's favorite alias, anyone would say out of their sleep that it's Art Vandelay.
I also know the word, but just because we
talked about
it before.
Yeah. But if you ask a RAG system what is George's favorite alias, then...
What is the RAG system? Who do you ask?
Any RAG system. You take OpenAI Assistant, any RAG system from LangChain or Llama Index.
What is your corpus?
And our RAG system. And my corpus is like every transcript of every episode ever aired in Seinfeld.
So, like, the data is there. It's just like a really hard time. Like, they have all the information.
Yeah.
Theoretically, they should have been able to answer that.
Yeah, exactly. And they fail miserably. Because there is not a single place where George is saying, my favorite alias is Art Vandelay.
Something very natural to say, I
guess. He just uses the alias in various occasions throughout the show without stating explicitly that he's using an alias. You just find it towards the end of the episode, or you have to have context from previous episodes. And Adversarially, you can say even that there is an episode where he demands his boss to call him T-Bone, and maybe this is the right alias for George. But any Seinfeld fan knows that it's Art Vandelay. So this question really challenges classic retrieval part systems.
And is there something that's currently like new works or something else that can actually solve this problem right now, or like a step in the direction?
Yeah, so lately there are some works in these directions. One of them I think worth mentioning is GraphRag by Microsoft that tries to convert the corpus, the raw corpus, unstructured words into some knowledge graph or other data structure which they can query afterwards. So maybe in this data structure they can write George aliases are Art Vandelay, and it is mentioned 6 times, and T-Bone is mentioned once, and then I can answer the question.
So just like a much more complex structure of like the RAG system.
Yeah, it's not necessarily much more complex, but it's not based necessarily on the raw data. It's more of like a holistic approach that takes the entire corpus and treats it like many facts that should be ordered in some way in some data structure.
Gotcha. But okay, so like we will see now a lot of works in the form of GraphRag, or like people do still work on RAG systems.
Yeah.
This will go over, or this is like something that's here to stay? This is something that...
So I'm not sure. It depends on how people are treating the RAG systems, because if you consider actual RAG systems and how people are treating it, they're usually mainly focused on the existing benchmarks that I talked about. GraphRag invented their own benchmark, and it's theirs, and it's no one else. No one else has it. So when you're coming to build a new RAG system, your ability to test yourself is very limited and very local, and many people are just revolving around this point of local optimizations on local questions.
So it seems that if I got the pattern right, okay, I'm now building a RAG system. I want to see if I'm good, so I'm testing myself on benchmarks that are flawed inherently. I'm trying to optimize to be best on those benchmarks. And then people say, well, let's build new benchmarks, roughly in the same way, inherently bad. And then I'm doing some improvements on my RAG system. So there's kind of like a vicious circle here.
Yeah, exactly. You said it right.
I took your words.
Yeah, thank you for that. So yeah, there is a vicious cycle here. Just the local benchmarks leads to local solutions, and I can say on my team, we were busy months trying to optimize around these local benchmarks.
So how do you, like you said it in past tense, which is great because it means that you kind of broke the circle. But how do you do that? Like how do you, like, and I know that, and I think a lot of people know that, right? From master's degree, from other projects, like you're so heads deep into something, and this is something which is really tempting, like get a bit more, few more points on some sort of a benchmark. How do you say, no, let's stop, let's like zoom out and start evaluating what we're doing here?
So I think it really took us a lot of time to come to this realization. But eventually we found ourselves optimizing benchmarks, and every time a new client came in, he was not satisfied. They were not satisfied. However, even though we were pretty good on those benchmarks in terms of the industry or other people publishing the results, we were quite good. But when a new client came, it always demanded other work, other overfitting to the data, to their questions. And we found ourselves giving a lot of our job to an external, like a solution architect or someone that engages with clients and trying to overfit to their data. eventually it turns out well or good enough, but I think we have a lot of potential there. So we said, no more optimizing there. It's good enough what we have here for the local questions. How do we engage with things that are beyond the scope?
I think it's something which is really like important for all the algorithm developers or researchers in the industry. Like, it's nice that it works, right, on a, how do you say that? On a ball in a vacuum? That's like the physicist way. Like, when everything is nice with like academic data, but you really have to make sure that you have some sort of data from the real world, from clients or something that mimics that, to see if it actually makes sense, right?
Exactly.
So we talked about, right, it's important to have something that actually mimics real world tasks. I'm guessing that you did something like that, right?
Yeah. So we tried to, let's recall what we tried to do. We tried to formulate the missing parts in today's benchmarks. And we concluded that overall, in bird's eye view on a corpus is missing, and the questions that consider the entire corpus are missing, and also questions that consider long-term relationships within documents or across documents.
And also, right, we talked about the fact that we want a benchmark that actually tests the entire end-to-end system.
Yeah, you're right, exactly. So we started with the FIFA World Cup, to your disappointment.
Fun. Yeah, let's talk about FIFA World Cup.
Yeah, so super interesting, actually.
Is it though?
Yeah, it is. So we took all the Wikipedia pages of all the historical FIFA World Cups, and we considered these pages, these raw pages of text, alongside other data sources that are organized within a data structure. Behind Wikipedia, you have Wikidata, which is a knowledge graph describing Wikipedia. We combined it together with Kaggle competitions, data sets from Kaggle competitions. And then
all of them related to FIFA World Cup?
All of them related to FIFA World Cup. Each and every item in these databases or knowledge graphs was validated, and we actually tested every single detail that is actually inside the Wikipedia pages. For example, if we say that France was the winner of FIFA World Cup 1998, then we tested that indeed this was the right, the actual case.
That's literally the only year that I know the winner of.
Exactly.
Only one.
Amazing. So what did we do? We took this data structure and we say, hey, this is a compact structure that describes many of the things that are discussed in these Wikipedia pages. And we can take this data structure and manipulate it a bit, and then we fed it to an LLM and asked for an SQL query that queries this data set alongside a natural verbalization of this query. This way we are getting queries that consider the entire corpus, and they're asking questions which we annotated as natural, and we even an unbiased spectator would annotate them as natural as we tested. So we got natural questions that consider the entire corpus. So I'll give a question to the football fans or soccer fans in the crowd.
So not me.
Not you.
You can look on the camera if you want.
Yeah, hi. So, for example, which team made it to the top 3 but never won the FIFA World Cup?
Croatia.
From
98.
Yeah, they reached twice again, I think so.
Nice.
So I think it's a super interesting question. Any soccer fan knows that it's a fact that can be described during a game, can be referenced during a game. It's interesting. I want to know the answer to this question.
Interesting.
Yeah. Sure. So we built this data set, and we combined manual annotation and automatic creation of the questions and the answers, and we took it for a test ride. We took it to OpenAI Assistant with GPT-4o as the underlying model, and the results were really amazing for us because the results were
100%?
No, not exactly. Under 10%.
Under 10%. So why is that amazing?
Because it's exactly what we wanted to show. To answer a question, which team made it to the top 3 but never won, you actually need a list of all the winning teams in history, and then you should, and all the top 3 teams in history, and doing like a set comparison, which is a difficult task for RAG, or may I say impossible task for RAG. And as you can see, it's not like a complex or intricate questions such as the my wife's name, as we said before, with the cigarette company.
But then I can actually understand it more now when you spoke about the fact that there I just had to decompose it to questions. Here it's like I need to decompose it to like actions or something like that.
Yeah, because I don't know how many World Cups have there been. I need to have some prior in order to decompose, or I can just decompose. And World Cups is something that everyone should know, even if you don't.
Happens after every 4 years.
Yeah, great.
That was what you wanted to say?
Yeah.
Oh, okay.
But in real use cases, if you consider real use cases, enterprise data, you don't have these priors. You don't know that you should look for a World Cup every 4 years and you can decompose that way. You just don't know that. And by the way, the World Cup did not happen every 4 years because there was a World War II. Here is another World War II reference.
Oh, that's like another cycle here.
Yeah.
I'm sensing there's a theme.
Yeah, the theme.
I'm not sure it's
relationship. Okay, so we had this data set and we were very, very happy with the results because it showed how much room for improvement we have there. And alongside this data set, we built 2 other data sets. The Seinfeld, which we go back to. We took every transcript of Seinfeld alongside other facts about the episode, such as air date and the number of viewers or such dry items. And we asked questions that consider the entire corpus. But what sort of questions consider the entire corpus? In this case, trivia questions. Trivia questions about Seinfeld are not just looking for a specific fact. They are not just looking to see if you know what was the name of the episode that.
What was George's
But what was
alias?
George's favorite alias?
I can't hear it anymore. Give me another example, please.
Yeah, I think maybe what is Festivus?
What is it? I will check the data set.
Yeah, check it. I think there are local questions there, but there are many spread questions, things that you need to understand. Maybe you will relate more to our third data set, which is Harry Potter books.
Oh, now you're talking my language.
Yeah, Harry Potter books alongside trivia questions about Harry Potter. And then you take a simple question of why did Professor McGonagall accepted Harry to the Quidditch team?
Oh, I know that.
You know that, exactly. Any Harry Potter fan may know that, but it's not written explicitly in the book anywhere. It's just like a mix of items that happened in the episodes, in the chapters before this chapter, where Professor McGonagall takes him by the hand to Wood, the captain of the Quidditch team, and says to him, "I found your seeker."
Yeah, it's like a whole chain of events. You're like missing a lot of details right now.
For sure, I'm not the Harry Potter fan you looked for, but there are many details, and that's exactly my point. Wood is the Quidditch captain. We don't know that. It's not written in the same place as where.
No, only afterwards.
Yeah, only afterwards. And you see where I'm going with it. In order to answer these questions, you need to know like 3 chapters before and 2 chapters after, and feed everything to the LLM to try, and it should try to look for the answer.
And all of these benchmarks that you created, all of them like score really, really low?
Yeah, all of them score really low.
Like 10% or less?
No, I think the Harry Potter and Seinfeld, as I said, trivia questions have a tendency sometimes to ask local questions where existing RAG systems are good at. So I think we're roughly around 50%.
But you actually have like the distribution of like the correct answers. Are they local or not local?
Yeah, they are all local.
Everything that good
everything
is
that
local.
is good is local.
That's great.
Yeah.
That's like a lot of room for improvement.
Yeah, tons of room.
I do want to like maybe ask, right? Because in the beginning we talked about the fact that most benchmarks are either for the retrieval part or for the augmented generation part.
Mm-hmm.
And you did mention that this is an end-to-end benchmark. So how do you, like, when you switch the language model that does that generation, can you like say that, oh, it's stable enough, like it actually tested the retrieval, or did you do the other way around, like switch the retrieval part? Like, what can you share a bit maybe about like the robustness for everything there?
Yeah, so our results were consistent across several models, like state-of-the-art models, ChatGPT, GPT-4o, Claude, Sonnet, and others, and several RAG pipelines, and we did the entire product of these things. So we know with high certainty that these results are reliable, and we can see we even did our own error analysis or false analysis, where we took the actual return segments and we read them ourselves, and you cannot you cannot know the answer from these retrieved segments.
And also, just like we talked about retrieval benchmarks, augmented generation or sequential answering benchmarks, but you also said that the chunking part or the splitting part, this is very, very important. Is there like a splitting benchmark? Is this benchmark will be for splitting?
Not exactly, because splitting is actually an artifact that is dependent on the question. If we go back to our World War II example with the reasons, so for one user, the good chunk is the entire section. And for another user, just the subsection that describes a specific detail. So different users require different chunking methods, and it depends on their use case and their needs and their questions, but you don't know them ahead of time.
So it seems that chunking is here to stay, right? So can I get maybe some tips for chunking from you?
Yeah, so chunking is here to stay for the short term, definitely. And I think that most importantly, you should try to realize what is the distribution of questions that your users are interested in and decide on your chunking method accordingly. But if you don't know, I would suggest using a large overlap between chunks so you don't lose anything in the boundaries between chunks.
What do you mean large overlap? Like 15%?
Like 50 or 60%.
50%?
Yeah.
Okay, that's a lot of overlap.
Yeah, that's a lot of overlap, but you would like to have the ability to see what happened before or what happens after in order to answer a question.
Okay, so essentially you're saying, like, if you know the user data, the distribution, really like use that, right, to have
overfit to the user data, always the best option.
If you can, but like chunking and indexing is not something that is very scalable to do every time, right? Something that you do once in a while. So you recommend to really start with big overlapping. Any other maybe
big overlaps, maybe other heuristics that are not specific to the distribution of questions, but maybe to the distribution of documents. If you have many documents like chat documents, you're trying to do a RAG over your Slack channels, then maybe you would like to refer to that. What is a document in this setting? How do you chunk things? How maybe you don't want to chunk things, conversations mid-thread or mid-day. I don't know.
Yeah. So, like I think we talked about the size of the chunk. Any recommendation how to choose that?
Again, depends on the user questions. I'd say maybe go with both. Both large chunks that would capture the high-level ideas and small chunks that would capture the fine details.
So not necessarily like you don't force all the chunks to be on the same size. That's
No,
what you're saying. It's
not
even,
necessarily.
Like, encourageable. Like much better that they will be meaningful and the size like doesn't matter.
Yeah.
In this case, like,
it complicates the pipeline, but I think it's worth it.
So, okay. So just like to sum everything up, let's collect kind of everything we said here, and maybe like the most naive question is, how do I start building my own RAG pipeline other than just go and like my first notebook?
So I think the first step, like in any other machine learning or algorithms problem, you need to understand what is your metric and what is your objective and how do you measure yourself and what are the benchmarks that you want to optimize on.
Give me 2 examples for benchmarks.
I think that if you are like doing the most naive or regular RAG pipeline, I'd go with natural questions. And if you want to go to something more difficult, maybe Hotpot QA or Finance Bench, or maybe CRAG.
When is the time to say stop optimizing for this benchmark and start working on something real?
Whenever you have real data in your hands. But I think more seriously, I think you have to understand the use cases your company is dealing with. And what are your clients, who are your clients, what interests them. But be aware that this pipeline that we talked about will not capture everything. It will capture only a small part of the world.
Common pitfalls that people go to?
I think the heuristics around chunking are infinite. You can just go on and say, let's put the header inside the chunk, and maybe we'll put the header before that also inside the chunks. And if I'm in a list, let's put the other list items in my chunk as well. And what about a table? If I'm splitting a table, maybe we'll take the headers as well. And it just goes on. And then in real life, people are not just contextualizing through headers and lists. People are just contextualizing through text.
And I think I kind of get the idea of the answer, but I will ask it for you. I will ask you that anyway. Is RAG a solved problem?
So I'll tell you the truth. I thought so. When I just started with this team, looking at Twitter and seeing all the RAG work and hype, I thought I'm coming to a solved issue where I can just collect the crumbs that people left there. And then you get 5 to 10% on a benchmark that you built, and you say, wow, this benchmark is interesting, and you understand that the problem is far from solved.
Well, thank you, Niv. It was such a good fun to be here with you today.
Thank you.
Thank you. All the things that Niv mentioned, the interesting articles, some examples, you will find in the description. And see you again next episode.